Suppose that we want to solve an inequality f of x greater than 0, and suppose that we know the graph of the function f of x. In lesson 2 we learn how to find values of x for which f of x is greater than 0 or f of x is less than 0. We use the fact that if f of x is greater than 0 on an interval, then the graph of f generated by x's in this interval will be above the x-axis. So to solve the inequality f of x greater than 0, we have to identify the parts of the graph that are above the x-axis and determine the values of x that generate this part of the graph. Similarly, we solve inequality f of x less than 0. We look for the parts on the graph that are below the x-axis, but not on the x-axis. Now, if in turn I want the solve inequality f of x is greater or equal 0, I will have to look at the parts of the graph that are above the x-axis and on the x-axis, because the f of x is equal 0 at the points on the x-axis. So let's look at the example. We have the graph of the function f of x, and we want to solve the inequality f of x is greater than 0 and f of x is greater or equal 0. So if I'm looking to find the value such that f of x is greater than 0, I will look at the parts of the graph that are above x-axis. So this part is above the x-axis. The whole part here is above x-axis, and the part right here is above the x-axis. So now to write the solution, I have to see what values of x generate this part of the graph. And I can see that every x are on the x-axis to the left of -2, not including -2 because for x equal -2 point is on the x-axis, and every point in the interval between -2 and 2, not including 2, will generate the parts of the graph above the x-axis, and also starting from 4 on, any x in this interval will generate the graph that is highlighted in red. And therefore I can write the solution f of x is greater than 0 if x is in the interval from -infinity to -2, union from -2 to 2, and the union from 4 to +infinity. If I want to solve inequality f of x is greater or equal 0, I will include the same intervals as before, but I will have to include in this solution the points that are on the x-axis. And the points on the x-axis and on the graph of that function are the points -2, 2, and 4. And therefore my intervals are going to be closed, and the solution is interval from -infinity to -2. I will close this because -2 is now included, and then I will include -2, and 2 is also included, and then union with 4 included and +infinity. However, if I write it that way, I can see that this is the interval from -infinity all the way to 2. The -2 is included, so there is no point in breaking it up. And therefore solution will be from -infinity to 2, union 4 to +infinity.